So let's talk about some trends in lattice energy. We won't always predict the exact number here, but there's a lot of useful trends. So remember, what we're talking about here is an interaction between a positive and negative charge. And this interaction is favorable, right? Positive and negative charges are attracted to each other, so this is favorable. And this comes from this equation. It's energy is equal to 1 over a constant times Q1 times Q2. So these are the charges. So if they're opposite charges, this will end up being a negative number. And so the energy is actually lowered over R. And so over R is the radius. So this equation points to two main factors in terms of how favorable a lattice energy is going to be. The first one that you want to think about is charge. It's the more important one. So higher charges, more favorable. Think about a weak magnet being attracted to each other. That's easy to rip apart. A super strong magnet, that's hard to rip apart. When we're talking about strength here, we're talking about the amount of charge. And so higher charge, more favorable. And then the other part of this equation is the distance part, the radius part. And so you can think about it kind of as gravity. The closer they are together, the more attracted they are going to be to each other. Think about two magnets on the opposite side of the room. There's no attraction there, but put them really close to each other and they'll pull themselves together. So closer together, more favorable. And we're talking about favorable, we're talking about kind of releasing energy, and so we're talking about more exothermic. And so overall, just to point out again, this one is going to have the bigger effect. So let's check that out. Let's check out charge first and look at the lattice energy of certain compounds. So we have sodium fluoride here versus calcium oxide. And these are approximately the same size. So size isn't going to be too big of a factor. Got a little picture here for you. So you can see they're both approximately 230 to 240 picometers, right? Not that big of a difference, right? 230, 240, approximately the same. What's different about them? Well, it's the charges, right? This is Na plus and F minus. This is calcium 2 plus and oxide, so 2 minus. And so if you look at the lattice energies here, this one ends up being negative 910 kilojoules per mole, while this one is a staggering 3,414 kilojoules per mole. So 3,414 kilojoules per mole. And more exothermic is more favorable. So much more favorable / exothermic. Think about a ball rolling down a hill. That ball is releasing energy. So things generally want to release energy. So higher charge, more exothermic. Cool. So we took a look at charge. Let's take a look at the different component, size. So again, use that analogy of magnets far apart in the room. They're not really pulling on each other. Magnets close to the room, yeah, they're going to pull each other. So let's take a look at some examples. So we have lithium chloride, sodium chloride, potassium chloride, and cesium chloride. So in all of these, we have a +1 and a -1. So it's not charge that's being affected. And so if you were to take a look at the lattice energies of these, you'd see this one's -834, -788, -701, -657. So the only thing that's changing is the cation here. So think about what's occurring as we go up the periodic table here, essentially. And I got a little picture for you here. So we can see here that the radius, as we kind of go up this row, this radius becomes smaller. And in terms of lattice energy, we can see it becomes more exothermic, right? So think about this equation too up here, if you want. It's over R, so as R gets smaller, that number actually gets bigger. So at the end of the day, what you got to know is as ions get closer together, the lattice energy is more exothermic. But it's not as important as charge. You can see the difference here is only like 150 kilojoules. All these are in units of kilojoules per mole. Whereas the charge stuff, the difference here is almost, 2,500. So the charge is the more important factor or the bigger factor. So right, not as big a factor as charge. And we'll do an example kind of question coming up.